Good evening. My name is Lee McWhorter, and I'm going to be your instructor for this Gray Hat 2020 training workshop, Advanced Exploiting Layer 3. I'm mainly just going to be a talking voice this evening, and only going to show a very few slides as we're mainly going to get hands-on in our graphic network simulator and playing with our range. This technically is a continuation of a class that I did last night, or at least when they're going to be played the night before. The Exploiting Layer 3 and Beyond, building a cyber range in a graphic network simulator. And this one, Advanced Exploiting Layer 3, is a continuation of that. It technically also continues on from the class I did at DEF CON for the Red Team Village, Attacking Layer 3. Both of those ended up with a similar range at the end, and if you followed the instructions, then you will have downloaded actually a starter project for this. You may be watching this video later, so one thing you'll find at the very end of the video is a link, and we'll go over it in big detail, to a resource document that basically has itself links to all of the other parts of this class. So we have the instructions and the starter file, the slide deck itself, and ultimately even a link back to the video. So preparing for the future and these living on online for some time to come. As I said, my name is Lee McWhorter. I'm the CTO of Coverage 6. We're a unique, veteran-owned and focused cybersecurity and security company. We are very unique in that we offer both training in all areas of physical security, executive protection, and cybersecurity, as well as we offer services in all of those areas. And we're actually the Department of Labor national standard for physical and cybersecurity training. You can find me professionally at LinkedIn and Twitter. And of course, I have a bunch of certs, but that's not really what we're here for today. What we're here for today is to talk more about what to do and how to build holistic cyber ranges. And so we're going to start with a little bit of an intro of a few things and kind of review. If you actually took the class yesterday or you took the class back at Red Team, just bear with me. There's only a few little bits of kind of review just to get us all on the same page, because obviously people can take this class without having taken those other sections. And so this is standalone, so I want to make it that way. So we're going to do a little quick review, and then we're going to start using the range that we've built, or the starter project that was built from previous classes, so that you can begin to see how it can be used. And then we'll start talking about layering some different things in additional defenses to make this very much a more holistic range. We'll close with some tips and tricks, especially if you want to build your own projects at some point, in challenges, maybe for teaching other people, or creating some kind of virtual capture the flag kind of a challenge or event. And we'll also then close with some additional resources, including that major important link to be able to go on. So one thing before we do go on is that there are instructions for how to set up for this class. If you took the Red Team Village class at DEF CON this year, or the class yesterday, then you already should be set up. Or if you happen to take that yesterday and then got the instructions from that, then you hopefully were set up by today to play along. I'm assuming most of you are set up, but I am going to cover some basic things just to make sure for people who watch this video later or who are having some potential issues getting everything set up. So we're going to start with those first. So if you're having GNS3 issues, I'll start with trying to give you a smile. One of my favorite sort of cartoons, and a couple others like the famous what are clouds made of? What's the cloud made of? Mostly Linux servers, right? But seriously, we're going to talk just briefly, and if you were in the last class, you already know this, and hopefully this worked to get you fixed. But there are a couple of common things that can go wrong in the setup of GNS3. GNS3 is a great open source package, and it is very much a great little tool once you get it up and running, as I think the participants of former classes can attest. But it does have a few known issues. The first thing to check is just make sure the GNS-VM itself is running. If it is not running, then the whole system breaks down. It's really three parts. There's the GNS3 software, there's something called the local server, which is really just running in the background, and it's the middleware piece that talks between the front-end GUI of GNS3 and the GNS3 VM, where all the magic happens. So if the VM doesn't work, then nothing else is going to work. So you want to make sure that the host-only adapter is correct. Though sometimes it's a known error that you first launch it, it comes up and it says it can't find the right host-only adapter. It's looking for a different one because of how it's made by GNS3. And so if you just go into your settings and go to the network tab, and then it should resync and update. Worst case, you can drop down and pick the appropriate host-only adapter that you will need, and then that should bring up the VM. Sometimes the VM will boot, and then as I will show you briefly, it will then tell you don't have KVM or kernel virtual machine support. That VM does need that to run some of the appliances, especially some of the higher end appliances you might want to run in a holistic cyber range. So the biggest usual problem for that is your machine doesn't support it. Your machine's BIOS or UEFI doesn't have the various features turned on for hardware virtualization support. That's less and less common, but it does still happen. Even had a recent batch of HP computers for our cybersecurity students come in, and we had to go in and turn that on all those machines. Occasionally you'll check and it is on, everything's should be working, but still the VM doesn't show it. So in B2 there is a line that you can run at the command prompt in the VirtualBox folder and run the VB manage program to modify your GNS3 VM and turn on that hardware virtual extensions. Usually those are the common problems, and that should get your VM running. Then ideally your VM will connect to the system and everything will work, but there are a couple issues as well with it sometimes, especially if the install didn't quite go right. Then maybe your GNS3 software, the client, the GUI, is not set up right. So you can launch it, go to Edit Preferences from the menu, Edit and then Preferences, and then we're going to see this later as well in a quick review. But you go to that screen and you go to the Server tab, and you are able to make sure that your host binding is set to 127.0.0.1, the local host loopback address. Generally, that's the model you want to use. And then if you are still having issues, you can also check in the Edit Preferences again under the GNS3 VM screen to make sure that the correct virtualization is set up. By default, they kind of default to VMware, even with a known issue about VMware Player at the moment that are in the instructions document. But I recommend you use VirtualBox. Whichever you're using, you have to make sure it's set correctly or they won't talk. If you're still having problems, then you can reach me at lee.grayhat@gmail.com, and that's an address that I have set up, and I'm hosting all the files for these classes for here this year at Gray Hat, and we'll use to answer questions about any of this. And of course, maybe I can answer some if in the live in Discord as well. So what are we going to then cover? Well, we're going to start, and like I promised, there's a very, very small slide deck, just a few, just to set the stage, and then we'll dive into actually playing with the technology and doing but we're going to start with a review of GNS3 for folks who may not have taken one of the previous classes, and then a review of the starter project topology, so everybody's on the same page. Ideally, everybody will have the setup. They will have this starter project or one from the previous classes that they themselves created they're using, and we'll build on from there. So what are we going to do? We're going to use the range a bit. We'll show you some basic scans, talk about some more advanced ones. This is my first time actually to do this more advanced class in this format, so I have at least one scan I'm kind of keeping optional. We may do at the end if we have time. If not, then we'll just talk about it very high level, some basic attacks, and talk about other things you can do within, obviously, that environment. We will also then talk about really building up these holistic ranges so that they're much more realistic. If the whole thing and the whole theme of the first class was to build a holistic range, the idea was instead of just having, say, a couple VMs that you're doing capture the flag stuff with, or building a little simulated network, that we can actually truly build a multi-node simulated network with router switches and all of that to build a more holistic range for learning and experimenting. Well, if we really want to take that to the next level, we want to add some other things in. So we're going to talk about adding in IDS, intrusion detection, talk about implementing some firewalls, and due to time constraints, we're only going to do a little of each of these things. But once again, this is showing you how you can add it. You can add more rules. I'll give you the high level. I'm not trying to turn this into a snort or a firewall class, but we will give you the basics so that you can work with that stuff. Then additionally, we will wrap up with some tricks and tips and do some additional resources at the end. So those that got a couple more slides at the end, then that's pretty much it. So I'm going to actually minimize, and we're going to dive right in. Now, I have already got GNS3 running. If you are playing along, then go ahead and fire up your GNS3. As a quick review for those folks that are new, GNS3, as I said, is a 3-part beast. There is this whole program that we're seeing now running actually with a project loaded, not running, but open. and we'll do a quick review, like I said, of GNS3 here. But then there's the local server piece, which is represented over in the server summary screen by your own computer. And then there is the GNS3 piece, which is there and is running in the background. If you just launched GNS3, when you first double click on it, and of course its icon is this friendly little gecko on your desktop here, but if you first launch GNS3, it flashes a little command prompt as it launches the server in the background and then brings up the GUI. But then you have to wait a little bit, and you have to wait for the VM to stand up in the background. It will boot up, and ideally then it will boot up to this screen. And generally we just leave the VM alone. If you were following the instructions, you actually played with it a little bit, and you will at some point to play it along, because you preloaded some of the Docker images that we are using and are going to use in this program. So it also shows you the IP address, so that you have that KVM support is true. And for the most part, except for my instructions having you preload, you generally just leave this thing sitting in the background, and that's where all the magic happens, as I said, but you do your real work in this GUI interface here. GNS3 allows us, as you can see, to build virtual networks. If you're jumping into this class by skipping some of the others, and you're new to GNS3, then what you're seeing, one thing you need to be aware of is that this is all real. They're running basically little virtual machines and Docker containers inside of that GNS3 VM. So this is an emulation, despite GNS3 standing for Graphic Network Simulator. It's really running VMs and containers, so you're actually get real command prompts and able to run these units as if they were real on metal or up in the cloud. And so in our case, in front of us, we have a topology, a small one, that is a simulation that has one router in the middle and a couple disparate networks, an outside simulation and a DMZ. And this is what was built in basically both of the Red Team Village DEF CON class version of this class and the class that was done yesterday. And so I took a version of that, cleaned it up a little bit, and then saved it out as the starter project for this thing and put it up for you folks. In my case, it's labeled Exploiting Layer 3 and Beyond because I built it doing that class, and now is continuing forward with this class. But as to continue the quick review, GNS3 of course has various menus. Really, I only spend a little time using some of the menus on the file, open and new, save as. You'll notice there is no save. We talked about that in the other class, but it saves dynamically. So if you do want to make a copy of something, you have to do a save as. There is also the way, and we'll talk more about this later, to both export and import a project. If you're played along, you've already done that, which is why you have this in. Either you built it from a previous class or you installed it and imported it, so you had it already built. GNS3 has these tools along the top, which are just redundant of that. Of course, the edit preferences is probably one of the most important things you do in the menu. So you could come in here and make sure that your server is enabled and your host binding is 127, that your GNS VM is enabled and the appropriate virtualization and everything's working. We also can use it to add custom Docker containers and even virtual machines as appropriate as well. And so but that's about all I ever use. I guess the other thing I will show that comes up occasionally is under the view menu is the docs. If you aren't seeing that server summary on the right, then you can pull that up and make that come up and visible so that you can show it off and be able to be aware. A lot of people make it go away later because once you're up and running and you have those two green dots and everything's good, then you don't have to see it. I like seeing the loads on my systems though, so I keep it up. It's completely a matter of preference, but definitely you're looking for these two green dots when you first start everything up. And if you have those, then the system is up and running and you should be able to move forward to either build a network or in this case, either you've built one previously or imported this in. We can add various appliances and I'm using this last button here. You can actually just look at routers or switches or whatever. I prefer just to jump straight to the all devices button at the bottom. And then this button here is the button that's used to go into cabling mode. So, and all I'm doing is clicking on things. It brings up a little menu. And I could theoretically cable something. I'm not going to. I'm just going to hit escape here because I don't really want to add another cable there. And you can see it's just an on-off toggle. So it's really easy to build these networks from the point of view of being able to use some of the default widgets that come, appliances that come with it. You also can use this new template as a way to go in and install servers. I'm not going to go through all of this because if you are taking this class without taking the other one, then at some point for some of that, you may want to go back and rewatch that first class. But I just want to hit the highlights of, the idea here is that you add various things in, and I'll show some of that at the end in additional resources. There's tons of tons of appliances that you can add in. There are not only ones that come from GNS3 or come from the community or commercial trials and various things that you can add to play with inside of GNS3 when you build networks, but you can pretty much build your own as well if you get into building some Docker images or just look at Docker Hub and find things you like there to bring in. So you can build with almost just amazing array of routers and switches and endpoints and targets and various things. And if there is something you would like to have in one of your ranges, you ultimately can build it yourself and import it in here and be able to use it. Once you add things to this device menu, it's pretty much just a drag and drop into the open workspace area, and you have to start setting things up. These are real computers, real router, real switch, and we'll play with all of these today so you'll get an idea of how this works. For the time being, since I've done all of this setup, and the starter project should look pretty much like this one for you folks, you will not need to be adding anything for a little bit, though we will talk about some other things we could do a little later, and one of those may be an optional if I actually have the time to get it done at the end of the class tonight. So basically, then let's see if there's anything else in my notes here. I'm just checking. Sorry. I think that's the quick review. One of the things that I guess I need to talk about as well is when you're within the actual workspace window, most of the time, while you can use these buttons up here to start everything or stop, pause everything, I prefer and usually teach that you use the right-click menus. Any object in the workspace area you can right-click on, and then you can see that it has a start. One of the big things that I want to talk about is this router. This router is a little mini virtual machine inside of here. It's actually one of the slower things when you actually run a full VM, as opposed to the other stuff in this topology is just Docker containers. So they're pretty light and they run pretty quickly. So I usually start with the routers. And the router is also kind of a unique beast, or kind of for the virtual machines more unique in that it actually, as I point to it, you see this little pop-up. It talks about having certain adapters. It has 3 network adapters. It tells you what the default username and password is, and it then tells you that it boots off of a CD image and you have to run install. Now, I ran install, but sometimes on my system it doesn't quite work. So if it doesn't, I'm going to probably do it again just to show everybody, or at least talk about it. But what I'm doing is just right-clicking and choosing Start, and now I'm going to right-click and choose Console. And I can see that, yes, this one, even though I ran the install, is either still booting off the CD or didn't take. I'm not going to worry about that at this point. I'll just show you how to go about setting it up yourself for your end. Let me get this a little bigger so we can see. So we'll let this system boot up. At this point, it's booting up like in my case, like a new, if you are booting correctly off the hard drive, the virtual hard drive in there, you should see your initial thing you should see is a grub menu countdown, and then it should boot, and it won't have this instruction of default username and password and to tell you to do the install image or install system command. So the one thing about this VYOS router, it's an open source router. It's very Cisco-like in its nature and in the way it operates, and so that's why I chose it. You can run Cisco routers inside of GNS3, and if you're trying to build a realistic topology mirroring, say, your company or a potential target or anything else you might be doing, then you can do that, but you have to have the licensing. So I stick to open source stuff, and so I picked this one because it's similar, and it's cool because you can actually just install it into a GNS3 project and run it off of the CD, and it works. The only drawback to that is it doesn't save its settings for next time, so you need to basically sort of recreate that again. So, and I'll do that in this case anyway as part of sort of level setting everything and getting everything back up and running. But I always boot the router up first, or routers up first, and wait for them to boot up and log in, because that way I know that what is going to be the slowest thing and take the longest to boot up is ready to go. And then I can begin to come in and starting up the rest of my topology. Usually just do it kind of in logical order like you might with real infrastructure. Boot the routers first, boot the switches, and then start booting your various devices. And so I'm going to let all this stuff stand up, and while I'm doing that, and I could have clicked this button, I tend to not, that's just me. If nothing else, I'm reinforcing the right click here, but that's up to you how you use it. My system is, for the most part, still at pretty much a default, including the VM has not been modified. I recommend a lot of times you go in and add more cores and RAM, depending upon how big of a topology you're going to build. But so what I want to do before we dive in a little bit further is let me just do a quick review of what this little starter topology is supposed to represent. It is using the assumption that the entire internet lives in the 10.x.x.x range. And so I have arbitrarily decided within that scope, which of course I know the 10 range, as most of you probably do, is just a reserved space class A, just like 192.168, only usable inside of networks, non-routable out there on the real net. But I'm just taking that class A and pretending in my mind and pretending in our simulation here today that it is the entire internet, and then arbitrarily have decided that 10.1.1.x is the outside. And then in the example of the DMZ here, this company has been assigned 10.10.10x, that class C, if you will, of the space, to be able to use inside their DMZ. And so ultimately, I have given devices out on the network, and I'll show them just through their mechanism. One of the things that is kind of nice is that you can at least configure the base and networking of any appliance within GNS3 just by using the configure option. You can always just boot the device, get on a prompt, and configure that device like you would if it was a real machine. So in the case of, say, a Linux machine, you might edit the etc network interfaces file. In this case, when we come to this configuration choice and this bottom down here at the bottom, network configuration, and click edit, we get that etc network interfaces file. And you can see I've already taken out the comments here and modified this to give this an IP of 10.1.1.100 and given it a gateway of 10.1.1.1. So I've given I'm just canceling out since that's already set. The Ubuntu guest has got 10.1.1.200. And then the interface on this router, and I know I'm cheating, by the way. I always get called on this when I do this, but this is a simulation. We're just setting it up. You can set it up any way you want to yourself and add more routers and things. I'm trying to keep it simple for a 2-hour workshop. But that interface has been given the gateway of 10.1.1.1. And then, of course, we just replicate that on the other side. This interface is 10.10.10.10.1. And then this machine, just because I use it and like it, it's 10.10.10.10. So, and we could add more things out here on the switch. The last thing we did in the course, and we'll come back to this, but this monitoring device actually doesn't have an IP. It's going to be set up later as passive intrusion detection. And so we have just plugged it in. Actually, if I point to it, it'll tell me that we plugged it into port 15 or the 16th port, Ether 15 on that machine. And we're going to set up some mirroring to change that so that we mirror the first few ports over to 15. And I'll show you that here in a little bit later in the class today. So all of these machines, and this one, I can once again just showing that configuration. It's set up as 10.10.10.10 with a .1 gateway. So this is, very simple simulation. But the one thing that we can do is, let's say I'm going to use this machine a lot, so I'll go ahead and start a console on this Kali Linux machine and go ahead and get its font a little bigger for our readability here today. And then I'll try to remember to leave this up in the background. But so if we do an if config, we have the ability to know that, yes, we do are an IP address. We do have that IP assigned 10.1.1.100. If we try to ping our neighbor 10.1.1.200, we should get success. In my case, though, when I try to ping 10.10.10, I'm going to fail. And the reason I'm going to fail, I can already tell you, is because since In my case, this starter project did not maintain its settings on the hard drive. I'm going to have to go back, and this will be a little review, but I'm just going to set it up real quickly. It will not take very long. I'm going to have to set back up the IP interfaces on this machine, which will be a good review if somebody's just starting out, as well as let me get running again so that I can get the demo doing. So I'm going to log in with the default username and password. I should be running the install image or install system command now to install it. I've already done that actually, so I think it's still just booting off the CD. I'm not going to mess with that right now. My purpose is to move on. In the VYOS router, and there's a lot of good information on their site that you can look up how to really get in depth, and I have some samples I'll show you of how to do a few basic things, including set up the IPs a little bit later. But there are two modes in the VYOS router. One is just an operational mode where you can do things like show interfaces, and in our case it's going to confirm yes I have them, but they're not up, I don't have them configured correctly. And so, you can look at all kinds of other stuff. We also, though, can go into the configure mode, and in that mode I can then, this is kind of like the Cisco enable mode, I can go in here and actually set the router up and do things like set up VPN, DHCP, firewall, on and on. And we'll talk a little bit about some of those as we go through the rest of the course tonight. So what I need to do, the interface is pretty straightforward. It's all either set SET commands or del delete commands, and definitely can use the magic of the up arrow and repeat and edit functionality of the command prompt to our advantage, since there's a lot of redundancy in the VYOS commands. But we're going to start with a set interfaces, and if you already have, of course, yours set up because yours worked, you built it in one of the other classes, or it's working on your machine because it was done on the starter, then great, you don't have to do this, and you can just sort of follow along for a quick second. If, on the other hand, the starter project is not working for you, then you can do this to get your internet, your connections up. I'm also using tab here. The tab completion is pretty thorough within the system. And so basically what I'm doing is, in this case, setting an IP address. So for the outside, the 0 interface, I need to set 10.1.1/24 so that I can have that outside interface be the gateway for those machines. There are actually two lines to completely configure an interface. One is the set interfaces Ethernet, etho or whatever address, and then there is the description line. And this is usually something like, just saying something like outside. As the case may be, you can give it whatever appropriate name you want to do. And then we can use the magic of the up arrow to basically edit here. If you're following along and having to do this, I'm changing that to 10.10.10.1 and changing it to Ethernet 1. And then I'm going to change the description, and to avoid messing up, I'm just going to type a lowercase z and change this to eth1 as well. And so now I have basically run the two commands I need on each of those interfaces. If we wanted to configure the third interface, you just do it again, and then you could have another router. I definitely have built many topologies where I use multiple routers and string them together, set up RIP or open source path first or whatever you want. All of those instructions are on the VYOS site. In my case, I just want to get my network back up and running for purposes here today, so I'm going to go ahead and commit that. And then I'm going to save it, though it probably won't take since I'm running off the CD, but just to complete the steps in the demo for you. And then I'm going to minimize this because we will come back to it later. But what this should allow me to do then, of course, is hit the up arrow here and show that now, yes, I have created a full network again. So if you had built your own and yours was already working, then great. If you needed to do those steps like I did just to get the basic interfaces back up for the router, and now you should have a working topology, a simulation of the outside being everything over here we would put on the 10.1.1.x network, and over here the 10.10.10 network. And of course, like I said, we could string another router off here and build much more elaborate topologies, but I'm not going to get that elaborate today as we continue on. What I'm going to do is kind of move into, okay, so we have this now. We built this in the previous class. Some of this has been a fair bit of review, so I apologize for those who did have to sit through that. Hopefully you learned a few things or it refreshed for you. Okay, we have this network now, so what kinds of things can we do? Well, just like a real network, we actually have now the ability on this Kali Linux command line to do various things. We can do different types of, things like as simple as, say, just Nmap scan that target on the other side for us, right? And very rapidly it comes back and shows us that, one thing you'll notice is we do not have DNS or DHCP in this case enabled at the moment. And I usually avoid setting up DNS inside of a GNS3 topology. You could, it's definitely doable, as well as definitely you can run DHCP, and I've done that, especially when I simulate a LAN. Sometimes I want to have DHCP running. The wireless router is pretty easy to configure as a DHCP server, but in this case I just do everything by my little convention of 10.x.x.x, and I pretty much only use the 10.1.1 and the 10.10.10, and it keeps it easy for me. Every time I build one of these, I know what I'm using. So in our case, that we got this Kali. Kali has now run an Nmap scan across the network and found that, of course, just a ton of stuff is open. If you don't know Metasploitable, Metasploitable is a purposely built is usually as a virtual machine. This has been converted into a Docker image and made everything run, except for a couple exploits that are basically, not part of the that require some of the older kernel modules to actually, or kernel exploits. Some of those do not work in this Docker or Metasploitable, just so you know. If you're following some guide and a couple things don't seem to work, that's probably because they relied on some older kernel, and which the real VM has. But since this is a Docker container, it's actually using a relatively newer Ubuntu kernel underneath, and as such, it doesn't support a couple of those exploits. But we can do any number of things. One of the things I'm going to do is just do a particular Nmap port scan, and basically I'm just going to add port 6200 here, because what I want to do is see if that's open or closed. I'm about to show a little pretty simple, many of you may know it, so that's not really the point of it, to teach you this little simple hack, because it's not something you'll find out in the real world per se, but it just to show that you can do all these things. We can exploit all the different things in Metasploitable. And so, like, for example, if we look back at our scan results here, we see that we have an FTP port open. If we and then I check just to make sure everything is set up right, and it is. So if I was to change that and do a little bit more of a scan, say this one, which is sort of the anything and everything scan on port 21, take a little bit longer for it to run this scan, but it's going to come back and tell me all kinds of things about this, including the fact that this is an anonymous FTP server. Well, that's interesting, right? I might want to poke over there and see if I can log in and see if I can find anything useful. But more importantly, it gives me the actual fingerprinting of that service. So it's running VSFTP 2.3.4, which, if you do not happen to know this yet, is a very infamous version of VSFTP that is specifically on here because of a backdoor that it has in it. And so, just to show a little playing and to show one, and it'll come back as we come back later and add some different things. We'll kind of do this a couple different times. But there is this, it's actually one of my favorite because at least it has a couple steps involved. But the quick story for those who don't know it is that VSFTP 2.3.4 was released into the wild, and I'm summarizing and kind of just simplifying, but basically a person had gotten involved in that open source community. They had joined and were helping fix bugs. They were checking in code. They were literally doing things to help the movement in a way, enough that they sort of got trusted and were ultimately then able to take advantage of and disabuse that trust to be able to check in a backdoor to this particular version. The backdoor was caught very quickly and then taken out. And so if you ever find VSFTP 2.3.4 anywhere besides a Metasploitable virtual machine, please drop me an email and let me know, because I've taught hundreds and hundreds and hundreds of students around the world cybersecurity in different aspects, and occasionally do this demo for one reason or another, just to kind of show our topology here. And the point is that I've never had anybody actually find it. If you find this in the wild, you have just won your pen test or won your challenge. You know, you're going to get in, because it's basically a root level backdoor. If you don't know how it works, it really comes down to you just have to interact with the FTP daemon over there on port 21 and be able to attempt to log in. And as part of that process, if you pass in a old school smiley face, hyphen and a colon and a closing parentheses, then it will fire up a port that you can then open up and have a backdoor shell. So it's just a demo of this working network and a very simple little hack that's in our target over there. I'm going to show you how to do this because we're going to use it a couple different times. One, to show what we can do in the network, and then also as we start to add things like intrusion detection, and particularly firewalls, see how that complicates things or gets in the way of things, as the case may be, right? So I prefer to do it this way. So what I'm going to do is just telnet over, I'm using the telnet tool to telnet over to 10.10.10.10 on port 21. That's going to connect me, as you can see here, to the VSFTP daemon. And if you're, of course, playing along at home, and you haven't done this before, then definitely feel free to do so. It's a fun little hack. If you have, then you can just watch if you know exactly how to beat this in your sleep. It's an easy one. I get that. But in this case, we're going to communicate. So we're passing in a username, and then we're passing in a password. It doesn't even matter what we pass in. What's going to happen is we're going to fail, obviously. But ideally, what should happen, and I'm just going to use control closing square bracket, which gets me out of that waiting for another login attempt so I can type quit. And then if I run my Nmap scan on port 6200, it's still closed, so I didn't do something right. So let's try that one more time. So we're going to telnet over here, set the R host, in our case to 10.10.10.10. And of course, if we use the up arrow and show our options, we can see that we've done that right. And then of course, all we have to do for Metasploit is run this darn thing. And it's going to go off, it's going to spawn the backdoor service, get our UI, and then ultimately open up a session for us. And in principle, we just recreated via Metasploit what we were able to do with the command line tool itself. And the same kind of things then apply. We can run those commands. Something about that shell requires the use of a semicolon after every line. And it's got some limitations, but you can see, very powerful. We could go in and start to really kind of mess with these people. We're going to abort that session. And at the moment, I'm just going to exit out of Metasploit. We may come back to it later. So as you can see, that's the whole purpose to me. Now, there are tons of other things you can do. One of the things that I believe I had you folks download, but I'm not 100% sure. And if not, then I'm not going to, actually, I won't do that. I know I didn't have you guys download that. But there are, when we get to those additional resources, there are other targets you can add, some of which I've built. I didn't have you add that, so I don't want to do it now because it would cause you folks to do a pretty big download since you didn't pre-download it. But I have, for example, a web server that is a little container that has a web server on it, and that web server has already been configured to have just a regular website on port 80 and then something else on port 8080. That could even be redone as well, but it has persistent web folders and web logs so that you could potentially use that as a target, set up anything you want to within that website, within those virtual websites. I set up the 80 and the 8080 for firewalls, which we'll talk about here a little later as we head into the last part of the class. And so there are a number of other things. There are dozens of attacks on Metasploitable. Not to make this an attack class, we're talking about ranges. But I wanted to basically, be able to show you that works and all these things work. Now, one of the things that also would require a little loading up, but there is a couple of containers within the store that actually allow you to get a web browser within this interface. So that means you can even browse to things like a website on here and actually hit the web page. If we have some time, like I said, I've got a couple things I may show at the end related to that, but I wanted to avoid those for everybody, so I didn't want to fill up everybody's drive with a bunch of images. we'll see what everybody decides to build themselves on their own. So the point here is that once we have this all set up, then we can begin to do things within that range. And of course, but if we just keep it wide open and all I'm doing is going from Kali to Metasploitable, then I could have technically done that just on a couple VMs, right? So if we want to add some more depth and richness to our cyber range, then we would start looking at doing some more layered defenses. So one of the things that I'm going to do here with you guys is we're going to spend a little time playing with this switch and with this monitoring unit right here. This is a container I built and had you download the darkstat snort container, and I just labeled it in this case monitoring. But it is meant to, I built it because I wanted to have something like intrusion detection or various types of monitoring tools within one of these topologies. I find it kind of fun, to say, for example, we could set up intrusion detection, and then is there any way somehow within this maybe you can get past that, right? Or even if it's not a matter of getting past it, it's a matter of learning from the fact that as you do an attack, certain things could be happening, right? And you could be triggering intrusion detection. And actually the way this is set up is one of my favorite ways to set up intrusion detection, because it's almost impossible for anybody to directly identify that that's even there because of a concept called port mirroring. So in the original class, we built these switches using a particular switch from the store called the Open vSwitch, which is actually like the VYOS router, both open source Linux distributions. And so if I bring up myself a console on this one, you'll see that various things have happened it's added all of its interfaces. Basically, this thing out of the box, if you just point to it, is a 16 port switch. And so we have really only a couple things connected, the traffic going off of the original, going back to the router itself in 0, and then we have Metasploitable here on ETH1. So what we're going to do is, and I'm going to be modifying for you, and then I'll show you how this works. It's been a little while since I've done this one, but I basically have a little snippet of code that I've used in a previous example. I'm going to tweak it because of this setup's a little different, and we'll modify it. Let me bring this back up though. So, and then just for a little bit, once again, since we'll play with it for a little while here, let's go to appearance and let's go to 16. All right. So this switch is a Linux machine. It has no IP addresses assigned because it doesn't need to. Instead, it's setting up all of its own Ethernets that are running as port switches, and of course it has a couple bridges already assigned to it. And so this software, this Open vSwitch, has its own interface, its own command. So just like VYOS, I don't intend on making this a Open vSwitch class. So there are tons of things you can do within this managed switch, though. You can set up VLAN. So if you're building like a simulation of a local area network and you need to VLAN some things off and you want to see if you can crack into another VLAN or something like that, then the possibilities are capable that you can do that. What I want to do is set up something called port mirroring. If you're not familiar with the concept because you just dove into this class, port mirroring is a really cool feature on managed switches where you can basically tell a switch to take the traffic on certain ports and literally copy it, mirror it to another port. And this allows you, for example, to monitor an entire segment of a network by having all the machines, say the first 15 ports of a 16-port switch, all plugged in with different computers, and all of that traffic being dumped onto that 16th port, ETH15, so that it can be passively scooped up and packet sniffed, and by some kind of intrusion detection or other type of security tool. It's a fairly common mechanism to do. They have their own way to do it, and so I got to find the appropriate. This one is the one I'm looking for. So it's a fairly complex command, and in this case, it's using this Open vSwitch vSet control, virtual switch control. It's going to set a bridge. And then I'm going to tweak this a bit because I don't want it to actually use port 4 as the, or the 5th port, ETH4. I want it to use the last one. And so I've got to tweak this just a little bit. And then ideally, what should happen is we're creating this ID array to store the different ports that we want to be part of this. We could obviously go on and add the rest of the ports. But I'm going to cut that off at just the first couple ports within this example and mirror all of that to port 15. This final line actually creates the ID, and I called it in this case IDS mirror, and it's going to take the source and destination being those first. Now you notice I'm skipping 0 because 0 goes to the router. So I just want to see stuff that's going on those first active ports, and that'll pick up our Metasploitable, and then we're going to output all that on ETH15, right? So in principle, if everything works as it should, I should be able to enter this in, which thankfully PuTTY lets you right-click a command in, and all right, I didn't get an error. I got a command code. I actually think that worked. That's supposed to. So with any luck, we should now have and I guess we can try just to see if, oops, I didn't mean to repeat all those commands. I wanted to go back to ifconfig. I don't know if it shows in this context or not. Oh, there's that bridge 0. So we did create it. I think we've got it correct. Cool. So just to go back and show that text again one more time, it's a little off the screen there. Let me make it full screen. So that is the code for Open vSwitch right here. What I'll do, to be honest, I didn't think of this, but I will add some additional links to the resource doc that I'll point you to at the end of this presentation. And some of these code samples that I have, I will actually post them, and you will be able to get them as well. So if you want to be able to cut and paste this into another, that's a lot to type, I admit. And so I probably should have put those in advance, but sorry, I didn't do that. This other command we'll come back to a little bit later. It's actually going to be our snort command. So in principle, what we've done here is we've created port mirroring on ports, basically, not counting the first one, 0, on ETH 1, 2, and 3, and we've mirrored all that down to port 15. So what that's going to allow us to do is come over here and get a console on this little bad boy, and you notice it's running secure shell in addition to some of the other things, so you could SSH into this within the topology from one machine to the other if you wanted to. I'm just going to, once again, get us a little bit better readability, and then what I want to do is I want to give you guys and girls a quick tour, because this is a neat little container that has a few things on it, but the main thing I'm going to talk about tonight is snort. Snort is an intrusion detection system. It's an open source intrusion detection system. And so I built this container because I wanted to be able to have snort inside of a GNS3 topology so we could have at least some degree of intrusion detection. And just like with VYS and Open vSwitch, I'm not turning this into a snort class either. But I want to give you a quick tour of it though, because I want you to understand. And then once again, the snort site, snort.org, if I remember correctly, has all kinds of great documentation, and you can get your own copy of it to download and install. You can get this container for GNS3 from the sample project, as well as my GitHub, not my GitHub, my Docker Hub, and so we'll talk about some of that stuff later. So the one thing about this is snort has been installed, and then snort keeps all of its configuration, like most programs do, under the etc etc folder. So if I switch over to etc snort, will be actually in the configuration folder. Now, one thing to be cognizant about is that this VM that I've created here maintains persistence of this folder. So everything that's in this folder, all of these config files, and even the subfolders like the rules and things, they are persistent. So even if you shut down your project and start it back up the next day, that'll be saved if you make some kind of configuration changes. One of the things that's really nice about snort is, like most Linux programs, from my opinion, is that most of the configuration is just text files, right? Little conf comp files. And so you just have to, kind of modify a little bit a text file with whatever editor you choose, whether that's in this VM or in this container inside of GNS3, or you're running snort real. Snort is popular enough to be run out there in the wild. I actually recommend it a lot to people in professional settings, even if you already have great intrusion detection on your network, right? It's kind of an aside cybersecurity point and pro tip, but if you're already a Cisco shop or a Juniper shop or whatever shop you're using with various endpoint protections and intrusion detection and intrusion prevention, next generation firewalls and all that stuff, that's great. I'm glad you got all that. But if you've got most of your eggs in the Cisco basket or most of your eggs in some company's basket, and then there's a 0 day for that company, you might be surprised someday, right? So why not have a few very cheap, either in the cloud or actually spun up on old hardware? Have your own backups, have some additional, it doesn't have to be Snort, do anything you want to, use one of the other open source, or go, if you just prefer to spend money, then go buy, if you're a Cisco shop, go buy a firewall or an intrusion detection from somebody else, so that you have that redundancy, that diversity in your layered defenses, right? So Snort is definitely something you would run into and might see again. Like I said, I'm not intending to make this a Snort class, but if you do want to play with it, one of the things that's cool is with this version in GNS3 that I built is, like I said, this folder is persistent, so you can try different things. And one of the things I like about Snort is Snort, you can actually make multiple configuration files. And though I'm not really going to make any changes, I will show you how to do that. So I'm going to take this snort.conf file and just copy it to, snort.conf.test. Okay, and as you see with an ls, I have two config files. They're identical at the moment. If I do a little nano or vi or whatever you prefer on this file, you can see that it is just a config file. I can come through here. Almost everything's commented out until you start getting into the variables. These are the key sections. Not going to go through all this at all, actually, but we have to set some variables, and then you can choose what rules and decoders and rule sets and all kinds of things on in here. And so by default, it just will track everything. But if you want to give it some of this information, like the IPs of your DNS server, like your HTTP servers, if you're really using it in a more elaborate topology, then this will allow it to focus its tracking on those types of resources. Otherwise, it'll just track pretty much everything. And you can see we can come down, there's all kinds of decoders, and it's just all text files. So you uncomment the stuff that you want to try, you comment things out you want to turn off. There's rules for everything under the sun, right? HTTP and web and SSL, all these different things that you can turn on. I'm just going to quit out of there. But we could ultimately try. You can make. I have in one of my programs, and I should say in some of my classes, I've had that be an assignment, right? You have to make your own Snort rules. You have to custom configure the Snort to go with a particular sample topology. And of course, in your case, if you're building a challenge either for yourself or for somebody else to try, then you can set these rules to either turn certain things on or off to make the challenge harder or easier to go with. In addition, if you take a look in the rules folder, this is a ton of rules that that are already built in, can be turned on and off. And so you can see there's different rules. These rules haven't, on this device, these rules haven't been updated in a while because I made this device a couple years ago and I basically baked in the rules because it's a Docker container. But it could easily, one of these days, maybe I'll update it and add a new one to my Docker hub. But it does what I want it to do, which is just, be able to simulate. It would be fairly easy to actually take my Docker container, bring it down, just update the rules, and make another copy. Make your own Docker container. If somebody does, please share it with me. But otherwise, I'll get to it one of these days. Now, a file to note, though, is this local rules file. And so I'm going to switch into the rules folder, and then I'm just going to take a look. Oh, we'll do it with nano. Why not? Nano local rules. And you'll see this says this is the local rules file. This is where you can create your own rules. And if I remember correctly, yeah, I have a few simple rules that are basically just throwing a fit if they see basic stuff like ICMP traffic, FTP, etc. traffic. So you could add more, and once again, there's help on the Snort site about how to write your own rules. So you can imagine with this, you are now really starting to add intrusion detection potentially into your system. So how do you go about running that? Well, I had the command, so I'm going to be lazy and just grab it here. Snort, there's once again other ways to run it, but one of the simplest ways, particularly inside of this topology, is to just run it. And I'm going to just clear for a second here, and then I'm going to actually go to a shorter listing. So when I post this in, you can see that basically the Snort command is snorts, and then there's a space for the option, and that's capital A. That will run the intrusion detection in a basically just an alert mode is what that stands for. And then the console is telling it we want to alert to the console. And then we're giving it the -c. That is to tell it what configuration file. Now, this is what's cool because like I could use that one. So if you make different configuration files to experiment with Snort and try things, then you can very much, play around and try different configurations. If it doesn't work, you can go back to the original one. You can, set those things up in different contexts for different challenges, maybe, so that you have different rules. Snort can be both set up as intrusion prevention, like in this case, because we've got it passively just sitting here looking at a mirrored port, so it's not in line with anything. But you could build a Snort or take the Snort container, create a new template with 2 adapter cards, and configure it to be an intrusion prevention and put it right in line with your target. So all of that's possible with Snort and with this container. And then the last option there is just what interface are we going to use. So we're going to be using the ETH0 interface. So if I go ahead and run this, you'll see that Snort fires up, starts loading up some rules, throws some little warnings about some flow bits, but that's all right. We don't really care. It'll hang at this point. This is one of those cases where you just got to wait for it. Then Snort should basically go on and continue to throw some more information on the screen as part of its login and startup process. And then it will finally say commencing packet capture, which is right there. And it even gives you the process ID for that. And because we're alerting to the screen, if anything happens, then in principle, we will see that come up on the screen. So let's see if I did this right today in our demo. So let's try to do something fairly simple. We're going to bring back up the just the old Kali over here. And technically, I'm pretty sure we had it, if I remember right, I had it set up. Let's see, it throws a fit about FTP. So let's just see if my telnet over to the FTP would actually cause that to go off. Well, oh, it did. So you can see the intrusion detection becomes an issue. Even though I was technically telnetting, since I telnetted to port 21, and that's what the rule's on, we're getting an alert that there is some attempt, right, to FTP. So I hope that you can see that that's kind of cool, right? Now, I hit the wrong keys there. Let me break out of that. Control square bracket and quit. So we now have some intrusion detection. And yay, I must have sacrificed enough pizza to the demo guides for once. That actually worked, the mirroring and everything. That's cool. Especially since I was changing a few things on the fly. That always concerns me. But nonetheless, it worked. Yay. So you folks should be seeing that, yeah, we now have a mirroring setup on this switch that allows us to capture the packets, and we could add other targets in here, and the same thing would apply. If we added them to ports 2 or ETH2 or ETH3, then they would still be part of the mirroring that we've set up. And of course, if we had wanted to, we could have mirrored all 15 to that last 16th port, right? And of course, that gets into its whole discussion of, is that too much overload for one intrusion detection machine? And that depends on all kinds of other stuff and is well beyond the scope of what we want to do here today. So, but okay, so we've added some intrusion detection now. That's cool. If, you can set that up different ways. It could be intrusion prevention, and talk about throwing a challenge in your way or into a cyber range you're building, so that if somebody trips the intrusion detection, they actually get blocked, or the port out here gets blocked. Now, even within the game of a cyber range, somebody could just add another device or change their IP, right? And so that, it's kind of interesting. And of course, the one thing that is a fair point as we start to talk about building some elaborate things is that you might have to be a little sneaky about how you build a range if you're going to export this as a portable project and give it to somebody, because they're going to get this whole thing. So technically they could go in and not turn on the intrusion detection. Mine is set to where you have to set it up manually. You could actually change that and make it so that it would boot up automatically, especially if you built a custom a version of that container. Or you could just have a script, in there that they need to run. Like I said, at the end, I'm going to talk about a few things that we could do to be able to add, more to the cyber range so that you can build some cool projects. Is one of the last topics I'm going to talk about. So what else? Okay, so we got intrusion detection now. and we could go in and customize that. We could customize the snort config file. We could update the rules, and actually I'll show you how to do that in that tips and tricks at the end, and how I even did it in this context. There is some, like I said, some neat little tricks we'll talk about with that in the last part. So okay, cool. So we've done our review, we've gotten in here, we've run an attack, and now we ran another attack, but it tripped intrusion detection. Okay, all right, well, that's good to know. That's kind of cool. So what else could we do? Well, one of the things that is obviously a very common thing, and a very common thing that's missing from our setup here, is that our firewall is wide open. There is no firewall at all, right? And so, once again, without trying to turn this into a complete BYOS class, we do need, because as I said, many of you may build yours with different. You may use Cisco routers. You may use the pfSense router. You may use some other open source router. I don't care. But you would want to add some degree of firewall at some way or another at some point as part of building your own challenges, either for others or for yourself. And it's usually, once again, many times one of the exercises that we have in our programs is to provide an open topology to a class, and then over time teach them some of the basics of attacks and logging and monitoring, and then be able to go in and for that matter, start adding things like intrusion detection, firewall, and teach them that as well. It's actually one thing, we ran that attack earlier, right? That little VSFTP attack from the Kali over to the Metasploitable. And now we have it being monitored, even though we're not logging that, we are alerting on it in our console. But one of the things I like to teach and even use, even if I'm building these just for myself, is many times I might be running an attack, say from the Kali Linux machine, right? So I'm running whatever attack over here, I'm running Hydra or something like that and brute forcing my way in. But I might open up a console on my target and go into the var logs folder and watch the log files of the service that I'm attacking. Because then this will show you what your tool looks like in those log files. So this isn't just a red team, it's because we're attacking and exploiting here. You can use these cyber ranges just as well to teach and to talk about blue team stuff, obviously defensive stuff like monitoring and firewalls, but logging, and you could add some of that in as well. You can literally build in full SIMs in here if you want to. I have a couple containers that I built I was attempting to build Graylog within a topology, and it was doable, definitely doable. I decided to abandon that project for my own efforts because it was too much for the topologies I was trying to build and provide to various classes, especially trying to keep them small. So, but anything that you can imagine, you can add in here. So the next thing we're going to talk about a little bit then is firewall rules, just briefly. So I'm going to bring back up, we had it here all along, this router, and we're still in the configuration mode because all we've done is set the IPs. So now we want to start thinking about setting firewall rules, and like I said, not to make this a firewall class or a BYOS router class, but we do got to talk a little basics real quickly. One of the things to keep in mind when you set up firewall rules is that firewalls, there really are three sets that you really should contemplate in true security. One, most people get focused on the traffic coming from the outside in through a firewall, or of course the traffic going from the inside out through a firewall. But you actually, in many cases, and definitely with the BYOS router and most routers, you should set firewalls rules that affect what can come to the router itself, the local rules. So you ultimately have three different sets of rules because it's just because you're stopping SSH from going through your router, are you stopping it coming to your router from the outside, for example. So you can set up different types of rules. Now, I'm not going to go through all of those by any stretch, and I just want to set up some real simple ones because of the interest of time. As a matter of fact, I may be running a little behind, so I want to get to definitely some other things. So once again, I have a little sample file that I'm going to use, and I will also make this available to everybody on the resource document at the end of the class, so you can download them later. So let me bring that up, and I want to just show you. It's kind of cool. I'll give it to you. I just call it this VYOS samples. And let me just go full screen for a second. And so up here, you got to go into config mode. We talked about that. This is how you set an interface, and that's exactly how we set the one. If you wanted to turn on the SSH on the BYOS and play with that, maybe even hack that router, that's how you can do that. This is how you set up DHCP. Just as an example, we don't have a LAN, but maybe if you added another, added another switch off and added a LAN down there, you could set up that and have it serve out through the LAN interface. And you can see you just do things. It's kind of a weird little start command to disable the serve as false, which really turns it on. But then beyond that, it's pretty simple. All of this stuff is the same up through subnet and the IP, and then you're just providing things like the default router, DNS, any name, lease, and what your range is. So a few lines, sort of like you have to have 2 lines to configure an IP, it takes a handful of lines to set up DHCP on a particular interface. And this name has to match the description that you've given. So we obviously wouldn't set up DHCP for the outside. That wouldn't be realistic in any kind of sense. But we can set it up on the inside or the DMZ or the LAN or however we want to. But that's why you need that second line to set an interface, because you need this name to use later for things like rules. So like this would be setting, these are the firewall rules. Now I'm not going to show all this. I'm just going to show a couple. And one of the things that I want to point out, not only are these here for my ease of cutting and pasting for our demo purposes today, but actually I really recommend for students and for individuals to write the firewall rules somewhere else. Write them, not only for BYOS, but potentially for other systems. And the reason for that is that you really want to be able to see, particularly in BYOS, like if you write these all out in Notepad first or some editor, you'll see if anything's off. If you misspelled something, like 2 A's here or something, you'll see that throws everything off, and so it won't line up. And so you can make sure, and of course cut and paste can be your friend here too. You can write the one line, cut and paste it, and then just change the parts you need to. You can get all this set up and save it in case you need to just cut and paste them back in at another time. Ooh, I hit a bunch of characters on my keyboard. My bad, didn't mean to do that. Let me get that back where it was. All right. So, and the other thing is that you can literally cut and paste these in. So this is basically 2 firewall rules itself, and then there's one more down here. So let's talk about the first one. The first one, unless you've never done or talked about or studied firewalls at all, you probably know the concept of the explicit denial, right? We're going to drop everything implicitly, explicitly, however you look at it. I am just going to drop everything coming in. It's sort of like the way home routers work. They don't let anything come in from the outside unless it's been requested from the inside. And that's what these next 3 lines do. And so you'll notice we have this default action, which we're going to drop everything. And then we're going to create our first, and we're using the concept of the name that matches our interface up here. So outside in, so this is traffic coming in from the outside. We're going to initially drop everything, and then we arbitrarily created this number, 1010. And you can create whatever numbers you want. I highly recommend you use some scheme like this, 1010, 1020, whatever, because if you ever need to insert a rule, rules do process in order, right? If you need to insert a rule, and you don't want to have to rename and redo all your rules, you want to just be able to insert one at 1011 or 1012. And there may not be a need for that, but you never know. And so it's better to have a little gap built in a sense. And so we can issue these, one at a time, cut and paste these actually into our router. You just have to right-click in PuTTY to paste in, and then we can hit enter. And if we don't get any error, then great, that rule took. Now the other thing is, if you actually select like this, including down to the next line, you'll actually copy the enters, and then you can paste in a bunch of these at one time, and they'll all happen and issue one at a time, one after the other, until you've set that rule. So now, look at what we've done. Let's go do something. We have now just set a firewall rule in place, and of course, earlier we were playing with the ability to do an Nmap scan of, let me get back to the one I want, just the standard scan of 10, 10, 10, 10 over there. Now, of course, this is a good lesson. It's still letting me scan. Why? Well, because I haven't committed those changes in the router yet. So let's do that real fast. Let's commit those changes. Once we commit them, take a moment to write back out to the configs or put them in place. And now, theoretically, if I've done everything right and luck is still with me today, it didn't. I'm still getting all those ports for some reason. Interesting. I wonder why my firewall rule didn't work. It should be dropping everything now. Peachy. Uh-oh, I spoke too soon about demoing to the demo gods, apparently, or donating enough pizza to the demo gods. That's interesting. I shouldn't be able to get anywhere in there because I'm dropping everything, accepting only if the state is established. Maybe somehow the fact that I've connected before is tricking it. I don't see, or I didn't. It should have been enforced now. Interesting. Just checking a few things out here. Sorry for the troubleshooting. Let me just see if I can ping 101010. I assume I still can. Okay, so yeah, it's not blocking everything. Interesting. What did I do wrong here today? Oh, I know. I'm a dummy. I am forgetting a critical thing. I've created these rules, and these rules are in place. Man, I'm sorry. That's on me. I'm forgetting that there's more further down this file. So pretend you don't see some of this for a moment, all these extra lines. Let me come all the way down here. We have to issue this command right here to set those rules on the particular interface. That's what I did wrong. So let me do that. So I set the rules right. Those are the two rules I was using, but I forgot that set line. So let me come back in. Thankfully, I didn't leave out of the configure mode. So I'm going to set those rules now. There we go. And now if I commit, knew there was something. Okay, I feel better. Whew. And now if I come back over here to Kali and I rerun my Nmap scan, I should get nothing. And I do. I get nothing. So as you can see, we can begin to really lock this thing down. Now, of course, that wouldn't be quite fun. So, what else could we do there? Well, we could, begin, and I'll just show one more example as I start to run out of time here. I've got other things to cover to wrap up in the next half hour or so. So let me just show one more. Let me go ahead and take this extra rule 1020 in here. Now you see what this is. It's going to allow port 80 to go through our firewall. So we're just like normal. We're going to open up things we explicitly want. That's a web server over there, so we want it to be open. So we're going to paste those all in, let them pop in one at a time. Cool. Then I'm just going to use the up arrow a handful of times and get to that set. I got to do that set line again, set interfaces. And now I will just commit. It's faster for me to type it. Boom, perfect. And so once that updates and commits, if I rerun my Nmap scan, and of course I could have rerun my attacks and everything else, but what I should see is the only thing I find open is port 80. So now this presents a challenge, right? If that's where you leave it, that means, well, I still might be able to exploit things. One, I do know that the Metasploitable has a number of vulnerable web apps, so we could get in over there. One of the apps it has on it is the damn vulnerable web app, which is vulnerable to just about everything, SQL injection and, of course, command injection. So we could probably, if we got creative with some shells and stuff, be able to get in and still pop ourselves a shell back out and exploit this box. But now you've seen we've taken this up a notch. You've only got so many ports. Now maybe we want to open up some other ports to simulate that email's open or other things are open. And once again, now we're limiting in this cyber range, making it much more holistic, making it more realistic, and making it much more of a challenge to try to beat some of those challenges or whatever challenges you may have designed for your group. So like I said, these are just some of the other examples. Here's some examples of setting local rules from the outside to stop anybody from being able to come in SSH. This is just an example of an inside-out rule. We don't even have an inside. It could be called LAN, whatever you want. That would allow stuff to go out and come back once it had the appropriate state. And you just have to continue to issue set commands. So I don't have an example set command that goes with that, but I do have example set commands that go with the outside-in rules, which you could, of course, modify all you want to and add more, and then the outside local rules, and then you could build and if you added another interface, you could build the other. And then you see there is this site right here, the wiki.bys.net. They have a user guide with all this stuff that's up there. So like I said, what I will do is I will take these little documents that I have produced that have some of these little quick cut and paste cheat sheet code, the mirroring code, the snort code, the BYOS stuff. and I will post those into my lee.grayhat@gmail.com drive and link them into the resource document so that you folks can get access to those and play with them on your own if you're going to continue to use some of these technologies like the BYOS router and the Open vSwitch. Sorry about the background dog. He's a hacker dog. He's a guard dog is what he is, so apparently somebody's coming to my door, so I apologize for that. Anyway, so let's see. Check my notes again. I think we're hitting the big highlights here. So we've added intrusion detection. We've added firewall rules. We could go so much further. I'm going to just do a couple things real fast, just to talk and to kind of be not necessarily review, but these are things that I'm basically going to add a couple other things from the library. And so if I go one and I go get a different guest, you can see all these guests. If you're new to GNS3, I didn't go through all this, but there's guests and firewalls and routers and switches and everything you can add. So I want to add this web term client. Web term, I'm gonna if you ever see the question to install into the GNS3 VM, the answer is yes, install it into the GNS3 VM. Unless you're in some corporate network where you're using like a GNS3 server for all of your engineers to keep their projects and work together. If it's just your own setup, it's going to be your own server. And so this says it's going to show up over on the side over there. So I now have the web term object. Web term is kind of neat, and I'm going to see if I can get this to add quickly and not cause me too much hassle. I'm going to stick it right over here in this topology. And then I'm going to quickly wire it into our outside switch, like so. And then if I remember correctly, I'm not sure, it looks like we can configure this one too, so cool. I'm just using that network configuration, going a little fast because of time, so if you're missing, I'm sorry, go back to the intro class and watch that. Oops, static, I'm almost editing the wrong place. So I want to come here, and then we're going to call this 10.1.150, kind of put it in the middle there. And then we'll give it, of course, the same 10.1.1.1 subnet. I mean, got the same subnet and 10.1.1 interface. Apply that. So I'm basically editing the Etsy network file so that hopefully its IP will work for me. I'm going to start this thing. This one usually takes a little bit longer to start, and this one, instead of being a command prompt, this one, when you open a console, oh, it started way faster. That is so cool. So this is actually letting me, through VNC, Virtual Network Computer, it's letting me run this browser inside of here, right? So I could do something like this. Just pop over to 10.10.10. And if it all works, yay, it is working. Things are working well today, except for me being a bonehead occasionally. So we've got damn vulnerable. So even with our firewall, we can now get in here and we can still mess around. And of course, you can imagine if you have a browser inside of that, opens up worlds. You could build a custom application for people to attack. You know, all kinds of things become possible. I don't know why we have a server not found tab there, but that's okay. This actually has its own menu, and it does have its own terminal, so you can still use it to do things. And of course, you know, one of the things we ought to do real fast is we ought to go back and check out our monitoring and see what's been going on. Wow, look at that. We've had various types of connections happen here from different machines. You know, so we're continuing to get alerts on different types of connections. And so you can see we now have the ability, even though we've put a firewall in place, we could theoretically say come into damn vulnerable, log in, and I think it's just admin password. Been a while since I've played with damn vulnerable, but if that's it, we're not going to save that. For damn vulnerable, you need to usually set your security level. It's usually set high. You might want to start low if you haven't played with it before, and then it really allows you to have some fun. If you want to have more of a challenge, you can go to high, but just using low for the moment, we could do something like we have command execution. We could basically potentially use the command injection feature here to open a shell back out to our Kali Linux machine, even though we only have port 80. You can see what I mean, that there's still attack opportunities, there's still options as you begin to build a more elaborate cyber range. I also have, if you want to add one more layer of sort of blue to the red and keep everything balanced, if you and I won't go through all the steps, but I have one of my own appliances. If you go to Edit Preferences, you would have to add it manually. It's under Docker containers. You would have to say New. You're going to run it in the GNS3 VM. And then I don't think I actually have it on this machine at all, even on this one. So I can't. I do have the other web server. Oh, there it is, the Net Defense Appliance. I'm going to go ahead and add one just real quick so you can see how this works. But this Net Defense Appliance, if you didn't have it, then you could type this in as the pull path into the new image box, and you would be able to get it that way. I'm going to go ahead and add it and just add it real quickly here. I'm only going to add one adapter, no defaults, everything's defaults. Tell it to apply. So what is the Network Defense Appliance? Well, it actually has a number of things on it. Some scanning tools like NIC2 and other things that you can use as part of, sort of teaching the blue team. It also has an instant copy running in Docker of OpenBOS. So if you were to add that, I'm not going to, I'm just showing you where it is. And if you added it, then when you assign it someplace on the network, you can surf to it and log into OpenBOS. There's an open copy of it on there. I believe it's on port 6800. Don't get me lying. It's been a little while, but you can definitely use that as well. So now we have a vulnerability scanner to add to the mix. Keep in mind, if you build topologies that you're trying to build as challenges to give to others, you may have to put rules in place, like whether they can add other things, or maybe they can, or whether they can get into your VMs or should at all as part of doing this, because you may not want them to be able to just cheat, right, and reprogram it. So there are a few tricks and tips, though, that I want to talk about real quickly as we sort of wrap up here, and then I'll get to the closing last couple slides and last information. But that is, if you really are trying to build some of these, not only for yourself, but possibly for other people, sometimes you want to do some other stuff. Like, for example, if you wanted to on Kali Linux, run some kind of Hydra attack, you can do that. But, what do you do to give, what do people use as a starter password file? They don't come with any on this one. So you can put one in yourself. You could create one. Or you could just have your students or your challenger, your challengees do one. I would tell you, if that's the case, then what you want to do is you want to store them in Gosh, what a day. Because this folder is persistent, so anything in here will stay. And as a matter of fact, once you create a project, like our project here, and of course I'm making changes to it, so it's changing. I'll save it out with a different name when I save the final version with some of this stored. Most of this will store, right? It'll continue to work. This will be added, this intrusion detection, mirroring will be set up, stuff like that. But if you need to put something in to, like you want to put some password files on your Kali, like I've done, or you want to put some scripts to run on one of the other machines, or you want to put some things that you want people to find in certain files that you want to put into these when you're building the project. If you put them in at the Docker level, if you were to create custom Docker, that'll work. You can put whatever you want to and then bring your own Docker images in. But if you want to not have them in the Docker, but just have them in the portable project, then there's a little bit of a trick. And I'll see if I can pull this off real quick. So if we take a look, it says that our VM, this is the GNS3 VM, is running on 192.168.56.102 for me. And it says I can log in as GNS3 at that with SSH. Okay, cool. Well, I use a program, if I can get it to pull up real quick, called WinSCP. WinSCP is a secure copy program. And so if I do something like this, 192.168.56.102, 102, username is GNS3, and the password is GNS3. I should be able to connect into this. I will get a warning the first time I connect to an SSH server that I have to trust that key. So I will accept that. And then I'm in here and I'm within the home GNS3 folder. So why am I showing you this? Well, if you want to do some cool stuff within your projects, if you actually connect into GNS3 and then you go up to the root folder, you will find that there is, in the OPT folder, is a GNS3 that actually matters, because you'll see it has all of your projects. So these are all the projects. Now, the challenge is to sort of figure out which project is which, because they use the strange hexadecimal naming ID system. But we can look at it usually by date. And so I'm betting, since I just created that yesterday, it's got to be one of these couple projects here that is the one that I'm playing with. So let's check out, let's see, this one hasn't been touched in a while, so probably this one, right, that I'm working on right here, even though this, well, can't really tell. We'll take a peek. So then it will show you the individual things that are in there, including your Docker containers. So, okay, now the challenge is you have to go back to GNS3 and, like, say for this Kali Linux, okay, so its ID, you can see right down there, is like hexadecimal CDFA4342. So let's go see in the FTP if we have that. CDFA, nope. So it doesn't look like that one's the right one. So let me back up into the other project. So we were looking at, what did I say? CD. Well, look at it again. CDFA4342. So it's not that one either. No, there it is right there. Okay, perfect. So it's this project. I found it, and then we can see we're modifying some of this stuff today that fits the time. So if I come in here, then you're going to see that the Etsy network folder is actually right there. And so if I was to hypothetically drag some, file, like a password file, or, bad usernames, bad password files into this folder, and I'm going to do something kind of small. I have this little gray hat. It's stupid, but what the heck. I'm just going to prove it to you. So I'm going to drop that in there, and then watch. If I come over here and take an ls again of this folder, there it is. So this is a way to inject stuff into the project. And what's cool is that when you export the project, that will save, and you will still be able, when somebody else imports that project in, then that will allow them to have that file too. So that's how I've distributed password files, I've distributed scripts, other types of things. I'm going to go ahead and delete that. That's kind of a silly one. But you get the idea, right? And so all you got to do is, the first challenge is figure out which of the actual projects it is. Once you figure out which project in the GNS3 projects folder, I know it's really hard to see there, but I'll just repeat it real fast. So from the root of the drive on the VM, the GNS3 VM, we connect down into opt GNS3 projects, and then you figure out which project you're working with. So in our case, I think it ended up being this one. And then you go into your Docker images, and that was then you can find that information here by pointing to any of these. So if we wanted to put something in the root folder, which is persistent on this, you see down at the bottom it says the root folder is persistent, so we could put something there. Generally, Etsy network is almost always persistent. And then so for example, this monitoring one here, this one is A718.4D. So we know it's in this same folder, A7, 1840. So if we come in here, there's Etsy network for the interfaces, but here's Etsy snort. And you can come in here and update the rules. And you would, even though you're not updating the Docker project, you're updating the most current rules in your project. And so when you then export that portable project, and I'm just going to cancel out of here, we're done with that. But that way, when we were to go out and say export portable project, we can include the base images, and it will include all of that data that we stuck into those things. So I hope you think that's a cool trick, because it really does let you build some really cool ranges and even put some other challenges inside of there. Sort of one of the last little tips is that if you do want to, say, block somebody from getting into certain things, then you can do one of two things. You can either build your own Docker containers. So you could build your own version of Metasploitable, take that mine, go in, change the username and password or something so somebody can't get into that root standard MSF admin account, and basically lock them out of it. Or you could as well, in some cases, potentially, now a more sophisticated user will sort this out, But most of the time when you connect to one of these things, you're connecting with Telnet, some kind of console application. But as you saw with the browser, that one, we connect as well. We can connect with VNC. Well, you can change this or give them none. And then when they try to connect, it's not going to let them in. So that's another trick. Now, somebody knows what they're doing, might be able to go in here and go, oh, I see what they did there, and change it back to Telnet and be able to get in. But it does give you some ability to at least obfuscate, if you will, the ability to to build these ranges, especially if you're going to distribute them in a learning environment for challenges within your community or at a con or something like that. So alrighty, so let's see. Let me just check some of my little cheat sheet notes. I did that, and that I covered myself, and we covered all that stuff. So at the end of the day, where you go with this is pretty much up to you. You could build whole elaborate networks with multiple routers, multiple switches, more realistic simulations of the internet. You can assign whatever IPs you want. You can build these for your own learning. And as you can see, you can layer in very elaborate technologies, including intrusion detection and firewalls, to really up the game, if you will, of being able, and make it more realistic, right? Make it that more holistic cyber range. And after doing all this, you're more advanced holistic cyber range. So let me, in my last few minutes, return to here, because now we've done those things. So I want to point out some resources. The Docker, dockerhub.docker.com is a great place to go. I won't repeat for everybody who saw it in the other class. Go back to those sites in this class, but open a browser, type these in, or once you get the link to download it here on the next slide, then you can come back and basically go visit these sites as well. So just go to Docker Hub, hub.docker.com, and you can search around and find different Docker containers that might be interesting to build into your GNS3 topologies. The GNS3, their own Docker Hub account, and mine, T. Lee Mick Jr. My name's officially fully Travis Lee McWhorter Jr., so that's where that comes from. That's my handle on Twitter as well. And so you will see that I have a number of different ones, even more than we talked about tonight, that you can use. And feel free, they're all open source, of course. And then the GNS3 Marketplace also is a great place to find other appliances and other containers to put within your advanced cyber ranges. And then, of course, build your own Docker. That may be the next thing I do. Maybe I'll do a class on how to build custom Docker images for GNS3 and for building cyber ranges. But I would definitely continue to help people on that. For myself, I did that. I created my own Ubuntu VM, set up Docker, and I do all my Docker work on that one VM. I check stuff into my Docker Hub. I have not, in the last couple of years, built any of these. Most of these have been around for a while, but they do exactly what I want them to do. You're free to take off and make your own versions or build from scratch. At some point, I may get bored enough to finally go back and update a few of them myself. One of the reasons I haven't bothered to update that snort is, like I just showed you, I can update the rules in a particular project. If I want to give a more current set of rules out, I can go download a new set from snort and then update them within the project, so I don't have to go back and actually update the entire, the actual whole Docker image itself. So, but anyway, this is that moment. Ding, ding, ding. I talked about it right at the beginning. And this is kind of how I've started doing these, especially these virtual cons, is since I, don't know what everything's going to be, I'm building a project on the fly and I want to give it to you and all that, and I don't have a way to share in advance the links for things that don't happen. So what I did was I just came up with this idea of, I have created this document on my lee.grayhat@gmail.com Google Drive. And so I will, it's a long Google sharing document link, but if you write this down, I'm going to leave it up here for quite a while. If you take a screenshot by hitting print screen and pasting it into something else, that'll capture the screen, or you can take a picture with your phone, whatever. You want to keep this URL. This is the master URL for this class. For anybody taking this class later, after it was done at the con, just watching the video later or whatever the case may be, this is going to be the key URL. If you go to this URL, it has a master document that basically has all of the other documents linked to it. So the instructions document is there, so if you were watching this later, or maybe you watched it live but you didn't get set up in advance, you can get the instructions document set up and start playing with some of this stuff. There's also the starter file that I started with that came from the previous class done last night, the Exploiting Level 3 and Beyond class. And then the project file that I've built tonight, I will save this one out and put it up there, and there'll be a link to that, the slides. And that's sort of a bonus. I hadn't planned on that, but since I am using a couple of these little Word documents that have a little snippets of code to set up firewall or mirroring and things like that, I'm going to also share those up on that site and make them available to you there. So that is the class for tonight. I want to really emphasize thank you for sticking out, especially if you get all the way to these last couple slides and through the whole thing. You've stuck the whole time again, and I really appreciate that. Had some great feedback and conversations with people working with this technology from my DEF CON Red Team Village class version. These are even the one yesterday is a little different, I think better than that one. So we got better, and now we got this advanced class to take it to that next level. So you can really build some advanced cyber ranges. But if you are having any trouble at all, please, even if you dove right into this class and you're just having trouble getting the GNS3 working, or you're having trouble with one of the actual containers or getting one of the actual virtual machines to work, happy to help. I would also encourage, of course, you spend some time at the gns3.com website. If you have already set it up, you've already created an account over there, downloaded the software and the VM, and you can use that account to log back in, go to the store, find other appliances, go to the forum, the community, and you can answer questions, search on things. If somebody else is very likely somebody's already experienced the same problem that you've experienced, and make sure you check there as well. I will be monitoring the lee.grayhat.com email address for some time to come. I'm still monitoring the one I created for DEF CON and occasionally getting an email or a question from students at that class. So happy to answer any questions and help you out. If there are any questions you have, then I'm very happy to help out, like I said, with that. And basically, that's the end of Advanced Exploiting Layer 3, a lab by Lee McWhorter, the CTO of Coverage 6, building a more advanced holistic cyber range in a graphic network simulator. And so I hope everybody enjoys the rest of DEF CON. I hope, or not DEF CON, Gray Hat, well, DEF CON 2. Go back and watch all the DEF CON videos. I'm still catching up on all that myself, so sorry. I hope everybody enjoys the rest of Gray Hat. If you're watching this during the scheduled time, then I hope you enjoyed the class. If you're watching it months from now, I hope you still enjoyed the class. And I look forward to hearing from many of you as you move forward to trying to build these ranges. Have a good night.